Okay, this is a short video to just instruct you in how to approach this problem. I'll also talk about it in class. And you can also buy some help if you want to trade in a few points. There's actually 10 extra points in the system, so you can still get 100, and you can trade in 5 points 2 times to get a little help. Okay, anyway, so let's get started. All right, here's the your grading sheet. The first thing we're going to do, you're going to show me your Viva board, each individual. So if you have 3 people, put all 3 names in, or ABC 1, 2, 3. And then if you demonstrate your Viva board, you get a check. It's worth 10 points. You start with 60 points, so that gets you to 70 right off the bat. Then your sheet will have a check here, and I'm going to give you an extra LED. It's going to be a little orange LED. It's going to look like this. Let me show you. So this little orange LED right here, and it has a current limiting resistor soldered onto one of the pins. You don't know whether it's the anode or the cathode. So what you have to do, you have to plug it in. Plug in one element to ground, touch the other one. So that doesn't light. So now we can flip it around. You can obviously use the 2 pins here. This is not a bad way to go. So we'll do this. Let's see. So see if that works. Oh, I see. No, that's sorry. All right, I'm going to temporarily unplug this. So I'll plug this in like this, and then I'll stretch this over here. So now I've got one pin plugged into the ground and the other pin plugged into power. Doesn't light. So now I'm going to switch it around. Plug one pin in there. It's a little tricky, but we'll get this done. There we go. And okay, so now I know that the long pin here is my cathode, and I know that the short pin is my anode. All right, so that's fine. So now I got that all set. So now that I know that, what did I have to do? Well, in this particular case, I'm instructed to have the anode, which is my short pin, plugged into RA4, and then the cathode has to be grounded. Okay, so that's fine. So I'm going to do that. I'm going to ground the cathode here. Going to put in my long pin to RA4, and I'm going to ground the cathode. Something's wrong there. Did I do that wrong? Yeah, I did it wrong. Okay, so the long pin is my anode. So in it goes right here, and then I'm going to plug the other one in to RA4. So power 5, 4. Now I've already got this programmed. So what it's supposed to do. All right. So you can see the rest of my sheet. I'm supposed to have the anode into RA4, which means the cathode has to go into ground, VSS. And then I'm supposed to blink at a 1-second period. Remember, the period is on time plus off time. So that's 500 milliseconds on, 500 milliseconds off. A 2-second period would be 1 second on, 1 second off. Okay, and then in the dark phase, I'm supposed to have a red-blue color on my RGB LED. So red on, blue on, green off. Here, I'm supposed to have green on, red, and blue off. But you could have some other selection. And then finally, my orange LED is supposed to blink in the light phase and be continuously on in the dark phase, not blink. So on in dark, continuously, blink in light. All right. So a little bit of a Halloween theme, if you will, here. Okay, so and then this is where we're going to do the grading. All right, so armed with that information now, I can finish my code. So what I'm going to do, and I'll show you my very simple loop. So the first thing I do, I'm going to give you this function down here called get photoresistor. And what that's going to do, it's going to do every time it goes through there, it's going to do all the setup and everything. It's a little redundant. You could do the setup once and only do just the set the 80 go and do this, but I do the whole thing. So we define a variable, light, an integer. We make sure that the analog function is turned on for RC3, which is the photoresistor input pin, and 7. We make sure that the tris bit is set as an input, and then we set ADCON1 for write justification. The frequency is FOS divided by 4, and then power ground and VSS and VDD is our plus and minus voltages. And then our ADCON0, we set the channel up for AN7 RC3, and then we turn on our module. We don't set the go down bit. And then we delay 2 milliseconds, and then we set the go down bit. We wait till it's cleared. When it's clear, we get the result, which is the upper bits in ADRSH. We shift them 8 bits to the left, add it to the ADRS low, and that gives us a 10-bit light result in light. We print that out so we can see what it is, so we can get our threshold set correctly, and then we return. So I have that printing out right now, and it looks like this. And if I make it dark, you can see it drops down around to 300, 400, maybe even 200 if I get real close and block everything out. You can see what I'm doing here in this picture. So if I put in, let me bring that back. You can see if I put my hand over the photoresistor, the numbers go down maybe to 190 even. If I take my hand off, they go up to almost 800. So I set the threshold at 500. You need to check your own threshold. If you don't want to use the UART and set all that up, fine. Then you can program it for debug, and you can stop the function and see what it is using the debug. And the way you would do that is you come up here, you click this icon, it should program it for debug, and then you go down to you create a variable window here, or we can do a watch window in debug, sorry, new watch, and so we don't have any global symbols, but what we can do is we can do our special function registers, and our special function we can do ADRSH, let's see, ADRSH, and you can do another one, ADRSL, let's see, where was that? Debug, new watch, and we'll do ADRSL. Okay, and then if you want, then you can add those. So they're not really here. Move this up to there. Maybe I can put this down there. Actually, we should be able to get rid of all these others. We don't need them at all. Oh, here they are. Okay, good. So now we have ADSRH. So what we'll do is we'll put a little stop in here in our code. So we'll do the stop right where we get photoresistor. We'll do it right after that. So we'll put a little stop, and we stop there. Now we read ADRSH is 03, so it's 0316 hex. You can also change these to decimal if you want, but it's better to look at the hex. So 0316, and then let's run it again with it covered. I'll put my hand over it, and then I'll click the run with my hand over it. And now we get, well, here's our photo value. So ADRS low, so the high was 0 and the low was E5. Okay, so and E5 is, I don't know, it's going to be under 200 decimal. Okay, so then all we have to do is put our threshold somewhere above that, maybe 500 decimal, or maybe 0x100, 0x100, 100 hex, which is going to be about, I don't know, 400 or 500. So you can play with the threshold and get it where it's in a good place. All right. Once you get the threshold set, then when your hand covers it, you'll be in the dark phase. When your hand doesn't cover it, you'll be in the light phase. So in my case, remembering that we want the orange to blink in the light phase, but not in the dark phase, and we want this color in the dark phase and this color on the RGB in the light phase, we can set everything up. You can see in my case what I did was, here's my while loop. So I get the photoresistor value, compare it to threshold. So if photo is less than threshold, it's dark. So then I want the added LED, which is plugged into, in my case, into RA4. I want it on. To turn that one on, since I have the anode into the pin, I have to make it 1, and the cathode's into ground. But if it was switched around, then I'd have to make it 0. Okay? So in this case, I turn it on. I do an or equal 1 shifted 4 bits to the left, and that turns it on. And then I want blue and red on. So in this case, I do an ampersand equal the tilde of 1 shifted 2 for the blue, and 1 shifted 6 in lat C for the red. And then I make sure my green is a 1, which turns it off. I do that with an or equal. Off, ampersand equal, tilde, this bit. On, or equal, no tilde, just this. And then, it drops through here, delays for half a second, and comes back. Keeps doing this. Now, if on the other hand, my photo value shows that we're in the light phase, now I'm down here. Here, I want my added LED to toggle, so I do an exclusive or equals 1 shifted 4. That takes care of RA4, my extra LED. And then I turn off the blue with an or equal 1, so I set it high. Remember, my orange is on when it's high, but my RGB works on when it's low, right? Your added LED could be set up to work the same as your RGB LED if I click cathode to pin, but I clicked anode to pin in my case, and so that's why it's the other way. And then finally, I turn off the red and I turn on the green. Then I delay half a second, and I come back and do this again. As long as my hand's covering the photo resistor, I'm going to do the else part, and I'm going to toggle this each time I come through here with a half-second delay, which then is going to give me the effect I'm looking for. So when I cover it, there's something. Oh, I see. Oh, I know what happened. This is broken. My little plug's got it. So you can see I'm in the light phase now. It's green and it's not blinking. Okay, I have a problem, probably. Oh, I'm in debug mode. That's the deal. All right, I'm not running. That's why it's screwed up. Okay, so I'm in the light phase. My orange is blinking. My green is on. Now, I'm in the dark phase. My orange is on continuously, and I'm showing red, blue, or purple. It's a little hard to see that. We can make it shrink down a little bit. I don't know. Never can get this right. Yeah, there's the purple. Okay, and so there we are. And when I take my hand away, it blinks in the dark phase, and in the light phase it blinks, and I have green. Again, that's what I was supposed to do, right? Light phase blinking, green. Dark phase not blinking, and showing blue-green. Dark phase, blue-green not blinking. Light phase, blinking and showing green. All right, and that means that's a complete success. Okay, so again, I want you to look at my code, and then I'm going to quit so you can get busy. Notice how simple this is. just this much. This is my entire program, plus this function down here. So I'm going to give you this function. Now, you have to get it right, and you have to pick the threshold nicely to make it switch back and forth. But you can do that if you print the threshold out, so you can actually see what's going on with the threshold. And obviously, you want to be able to see that it goes down to 200, goes up to almost 800. I did it in decimal. It's a lot easier for me to figure out what's about halfway between 800 and 200. I figured 500, I don't know, but 400 would have worked probably. So there's a lot of flexibility, but so don't spend a lot of time trying to super fine tune it. You just want it to be, pretty good, right? Okay. And the lighting in the classroom may be a little different than the lighting here in my office. All right. So I think with that, I'm going to stop this. Well, I'll just show you the grading. So let me bring that back up real quick. So what the heck? Okay. So yeah, it switched to the wrong camera. Oh, this must have come unplugged. There we go. I don't know. Went brain dead. Okay. Okay. So the grading. So this works down here. You're going to get, of course, you're going to get 10 points each individual for showing their own Viva board, and then you're going to get 10 points if you have your photoresistor working well. You'll get 10 points then if you have the added LED, the orange LED, blinking in the correct phase and solid in the correct phase. And then you'll get, if you have the correct colors in dark and the correct colors in the light on the RGB, that's another 5 point each. And then so this is, right, this is just, I may have to change this gradient a little bit. All right, so this is just getting the added LED set up correctly, anode to anode where it's supposed to be, cathode where it's supposed to be, and then this is getting it blinking correctly in the dark phase and light phase. All right, and so all total you can get 110 points. If you want, you can trade in 5 points to get a little help, and you can do that 2 times, so you can still get 100. And if you're missing some of these, you'll be fine. You start with 60 points. So if you just demonstrate your board, you get 70 points. All right. So that is, we'll end the video on that.